Hi everyone, this is Suraj. Today I'll be presenting my project, which is prediction of hotel booking cancellations. Let's start, shall we? So the introduction for the project is that the hotels, as we know, thrive on advanced reservation system. This system cut costs and saves times and also automates the entire reservation process. So many hotels now have cancellation policies, which allow guests to cancel the reservations at their will. This can be a little bit of a problem for the hotels as it is pretty hard to predict demand when a lot of people are canceling. So the aim of this project is to identify the reservations which would most likely be cancelled. The model mostly predicts those reservations which are made by the people who are not sure about their stay. So about the data set, this data set has been collected from Microtel BWI with the permission from the manager. It has 36,275 rows and 19 columns. Now looking at the heat map, we can see that there's no, this is SNS heat map. We can see that there's no white spot on the data set, on the heat map, which means that there are no missing values. There are no null values. So these are the columns in the data set. I have also additionally added three columns, which are price slabs, lead time slabs, and total nights. So price slabs is it sorts the values from the average price of the hotel room into slabs, well-defined slabs, and the same for lead time as well, lead time slabs as well. It slots the lead time values into lead times well-defined slabs, and total nights is the sum of weeknights and weekend nights. This is done due to so that it is easier to analyze the data. So if you look at the correlation among columns, you don't see like a lot. If we see with the booking status encoded column, I have added it for to include in the correlation data. We can see that it has pretty high relation with lead time slabs or lead time, which are the same thing. Um, from this data, we can see that as a lead time increases, the concentration of cancellations increases. So as the lead time increases, the chance of reservation getting canceled increases. Now we can see reservations with respect to months. We can see that the reservations are high during summer months, but for this hotel, the reservations are higher during the month of October. I don't know the specific reason for this. Let's continue. With respect to the week, we can see that weekends have highest number of reservations. Sources, we can see online has the highest number of reservations and followed by offline and corporate. These are the cancellation with respect to sources. These are cancellation with respect to total nights, and this is cancellation with respect to number of parking spots used. Basically, if a guest chooses a parking spot, he's less likely to cancel. Now, if we see cancellation with respect to number of special requests made, we can see that as the number of special requests increases, the chance of a reservation getting cancelled decreases. So coming to classification, as part of the first step in classification, I have split the data set into sets containing 80% training data and 20% testing data. And then I have defined a processing pipeline, which consists standard scaler for numerical pipeline and one hot encoder for categorical pipeline. These both are added into processing pipeline. And I have used this pipeline in every classification I have used. I have also used grid search for all the classification, also perform secondary grid search wherever necessary. Now let's look at all the classification reports. So first I did is logistic regression. Uh, I always do logistic regression for any data set because this solves most of the problems and is also easy on the computer and also pretty fast. So this model got an accuracy score of 77, which is not good, but not bad. Now coming to decision tree, this has got an accuracy score of 88, but it has better precision and recall values compared to uh, logistic regression, as we can see here. Next I did was random forest. This got the highest accuracy of all, 0.9 of all the three classifications, and also has good precision and recall values, which is a good thing. So the precision recall well is basically it's a good thing for this model. It also has an ROC score of 0.95, which is very good for any kind of model. And this is a gradient boosting algorithm I have performed, sorry, which has got an accuracy of 90%. Uh, this is similar to random forest algorithm, but this took a lot of time. This took around 20 minutes, which is like 10 times uh, more compared to uh, random forest. So it requires high computational power. So I don't think this would be a good choice for this data set. To conclude, irrespective of the price, hotel reservations are and will be cancelled due to several reasons. But dummy reservations can be identified using this model to get an idea of the demand, and also maybe forecast the income as well. Thank you.